two fire ranger towers. I do a lot of problems with these fire ranger towers. Lie on an east-west line. So this is north-south line, process of elimination, that must be the east-west line. So one is like here, another one is like over here on the east-west line. And are 5 miles apart. 5 miles. There is a fire with a bearing of fire. Fire! We didn't start the fire. Okay, fire. Maybe I'll even, ooh, fancy smancy. Okay. What are we doing now? Oh yeah, there's a fire with a bearing of 27 degrees northeast from Tower 1. So I proclaim that to be Tower 1, and bearing, draw north-south line. As soon as I see bearing, I'm drawing that north-south line. And it's 27 degrees from that north-south line. And then the other one, Tower 2, it's got a bearing of northwest. So if I travel in northwest direction, that's how I'd have to move. And that's made with a north-south line. That's 32 degrees. How far is the fire from Tower 1? This is actually pretty simple here. We know that both of these angles here are 90 degrees. So this angle has to be 63 degrees. This angle has to be 58 degrees. How far away is the fire from Tower 1? So we're trying to figure out that distance. I can do 180 degrees minus the 63 plus the 58, giving me this angle is 59 degrees. See how I'm just labeling everything I possibly can on my triangle? Well, now I can just use the law of sines because I've got an angle and its opposite side that can set that ratio. So this unknown distance divided by the sine of its opposite angle on that triangle is 58 degrees has to equal the side 5 miles divided by the sine of its opposite angle 59 degrees. Multiply both sides by sine of 58. And then I get that distance to be about 4.95 miles. So we'll call it an even 5.0 miles because I seem to be continually rounding to the nearest tenth. So that's how far away it is. Easy peasy. Next one here. A plane. Plane travels 675 miles from A to B with a bearing of 975, north 75 degrees east. So that means that it's going in a northeasterly direction. So here's A, where it starts apparently, and then to get to B, we've got to go in the northeast direction. So I'm going to throw B somewhere over in the northeastern side of A. Where exactly? I don't know. Apparently 75 degrees worth. So right off the bat there, the plane is going to travel in that northeasterly direction, and it's got a bearing of 75 degrees. So I'm going to draw automatically that north-south line, and this is the bearing right here, that north-south line of 75 degrees. And it says it traveled 675 miles to get from one to the other. Then it flies 540 miles from B to C. So from B it goes somewhere to C. Now where am I putting C? I'm not sure yet. Oh wait, yes I do. It's going to go 32 degrees north and east. So I'm going to continue going in the northeasterly direction, and I'll declare that to be C. It says it travels 540 miles to get there in this northeasterly direction. Okay, oh yeah, bearings, northeast. So that means if I draw my north-south line, that angle it makes with that north-south line is 32 degrees. Find the straight line distance and bearing from C going to A. So how long is it from C going back to A? So I only do that in a different color. They want to know how long that distance is, so maybe I'll call it lowercase b because it's opposite angle B on that triangle. And it also wants to know its bearing. So that means it wants to know, like, what is that angle that it makes in there. So that's kind of a lot of stuff to think through. I'm going to put this 32 degrees, I'm going to erase that, and I'm going to make that a little closer to the angle I meant for it to be. This angle is 32 degrees. A little later on I might get confused. I'm seeing though that these are all north-south lines, so thus all of those lines have to be parallel to each other, which might help us. So that means that this angle and this angle are congruent. Parallel lines makes those alternating interior angles congruent. And so we'll call that step 1, I guess. We also know that parallel lines, what about the same side interior angles? The same side interior angles are supplementary. So if this angle is 75 degrees, and that 75 degrees actually hits all the way to the bottom there, then this angle has to be 180, take away 75. So we'll call that step 2. 180 minus 75, that angle is 105 degrees. Now, why did I choose that angle? Because I'm looking at this oblique triangle and I'm trying to come up with as many angles and as many side measures as I can. So on that triangle, if I draw it out again, we know this angle here is 105 plus 32. So we'll call that step 3, I guess. Step 3. That angle is 105 plus 32 degrees, giving us a total of 137 degrees. We know this side was 675 miles. This side's 540 miles. That's really all that I need then. To figure out side B, I can just use the law of cosines. So B squared has to equal 675 squared plus 540 squared minus 2 times 675 times 540, that's a 5, times the cosine of that angle is 137 degrees. So with that I get B squared is this large number, and then I square root that, and I get that distance is 1,131.5 miles, which is one thing they were asking us for, is what is that distance from A to C. But then the second part it asks is find the straight line distance and the bearing from C to A. Read that carefully, from C to A. So it means that if the plane travels from C and heads to A, what is that bearing going from C in this? So there's the path that it would travel in. It would go in the southwestern direction. I got to figure out what that angle right here is. Actually, that's not true. Okay, it would be this angle here. It's got to be an acute angle. Sorry about that. So that would be our bearing from the north-south line coming from C going towards A. We need that angle. Well, if I can figure out this angle on the triangle and then I can add that to 32, then we'd have it. So to figure out how big this angle is, let's go ahead and use the law of sines with this stored number. So let's see here. That would be sine of angle, we'll call that C of angle C, divided by its opposite side has to equal the sine of that stored B number divided by the, oops, actually that's not true. The sine of that angle is 137 divided by that stored B number. And then after I multiply both sides by 675 and take the arc sine, I get the number 24.006. So we'll call that an even 24.0 degrees. So if this angle is 24.0, then this bearing has to be 32 plus that number. So 32 degrees plus 24 degrees gives us a total then of 58 degrees. So that's not the final answer though, right? It's the bearing. So we got to indicate a direction. To go from C to A, we're going in the southwest direction. So south 58 degrees west is its bearing. This is our last one right here, okay? For a second, okay, just imagine you're walking. So to approximate the length of a wash, a surveyor walks 950 feet from point A to point B. It doesn't say really a direction here, so I don't have to worry so much about that. Then he turns 80 degrees. Now, think about it for a second, okay? We're a helicopter hovering over this guy. It's a little creepy, but let's just pretend for a second. And we see the guy turn around 80 degrees. So the guy's walking along here. Walking along, and then you tell him, aw, dang it. Well, you don't really tell him, aw, dang it, but I was saying, aw, dang it. Okay, so then we're walking along, and he gets to B, and then you say, wait, hold it right there. Turn around 80 degrees. Can you imagine, like, if he turned around that much, that's more than 80 degrees, right? If he went around like that, that's not 80 degrees. If you asked him to turn around 80 degrees, okay, he's standing right here, there's his shoulders, and he turns 80 degrees, he's only going to be turning a little bit. So that means that he'd be turning like this much. Okay, so here's him continually walking forward along the path he was on, and then he turns 80 degrees and continues to walk along that path instead. This is the 80-degree angle that they're referring to there. Okay, so but he first walked 950 feet from A going to B, then he turned this 80 degrees and walks another 800 feet to this other point, which they're calling C. They want to know how long it is from A going to C. Well, if that's 100, if this is 80 degrees, then this angle would have to be 100 degrees. So this is actually a pretty simple law of cosines problem. Figure out how long this side is. B squared has to equal 950 squared plus 800 squared minus 2 times 950 times 800 cosine of 100 degrees. And so B squared is this number. And when you square root it, looks like that distance is 1,436 feet. So label your triangles the best that you possibly can. Draw the picture, draw the picture, draw the picture. Keep your answers very much exact for me. Also show your work on your tests and on your quizzes. If you don't have the work, how am I going to give you any partial credit? Okay, there's a lot involved on these problems. They're going to be worth a lot of points. So this is April Ann Rainey, and I am signing off.